Okay, hello world. This is day 164 of studying compilers every day until I land a compiler role. I'm pretty tired today, so I might try to keep the stream short. I can't really guarantee that it does end up short, but we'll see how my motivation goes. Last time we worked on more slush. Is the description italic? I don't know. That might just be you. But yeah, last time I forget what we worked on. I think we generated. We did some cleanup work. Let's check. Oh yeah, something about stack parameters. And just like cleaning up our implementation for that. Yeah, so that made a mess, but that is all good. But yeah, this time I think we're gonna try to generate a calling convention for just like everything else, to be honest, and then we can figure out the entry point for main at some point. Actually, I am kind of curious about this as well, so I'm kind of, we'll see. Actually, yeah, let's look at that. Actually, maybe this might be easier, but I'm kind of curious what it looks like. Assembly x86 64 entry point. Okay, I think we need some of this slush, I think. So we probably need these. Yeah, so presumably we want to be able to use the C runtime library. So CRT0, I see. I guess maybe this? I don't know. I think we just need to start with like a global main, if I had to guess. I don't actually know. This is interesting. How can we test this? Let's look at like its global start. I see. So let's clang test regression. Let's give it. Let's do that. Let's see. So it's like this slush at the top, I think. I guess we could nvim this maybe. I don't really understand a lot of this, to be honest. Let's maybe do this with like. What test do we do? Parsing, I think? Yeah, let's look at that. Ah, yeah, that. Oh, wait, I forgot to dash S it. Whoops. Let's get rid of that. Yeah, okay. So we have like this global. So what happens if we try to like. What if we just clang test regression input? Let's give it. What was the other test we did? We did call chain. Let's try that again. And did call chain have main? Oh, it did have main. I see. Yeah. So then what else can we do? Let's get rid of both of those. I think we can figure, we can build more things. Let's give it like SSA. Ah, I see. So it just doesn't link. So dash S. Yeah, so we have like this header stuff as well. Yeah, that's awkward. I guess we could loop through the functions and see if it has main. And then. Wait, that's very confusing, actually. How much of this is actually necessary? You probably, I think it's probably that sort of stuff at least. I guess there's also just a lot of slush here. We can just dash O0 it maybe? Dash S? Okay. Okay. Maybe we could like... Oh wait, what am I doing here? Dash. Yeah, we'll just... I don't know. This is not going as smoothly as I was expecting. I don't know. In the meantime, I guess we could just like generate some of the slush in the future, but I guess we know where to look now at least. Let's get rid of that. Okay. Yeah, today in the class I just came from before stream, we did a bunch of like fuzzer testing. So naturally I decided to fuzz Panic, and let's just say there were a lot of bugs that came up. So that'll be like something fun for me to look at in the future. I might try to figure out like how to automate fuzzing as well, or like have a fuzzer of some sort. That could be fun. Or maybe like I could look into like LLVM's fuzzer. But anyways, all of this is like secondary to what I want to do today. Let's figure out calling convention around call. And this might end up being a mess, so I'm a little bit scared. We like scaffolded it out last time though, so it should be a little bit less miserable. It still does not look fun, so yes, we have like this whole pile. So let's start by allocating the space. How much space do we need for this? I guess we could check which registers are live at this, or we could just like, yeah, that's really rough. Yeah, how do I even do this? I guess I probably need a better way to map things then. I guess the saving and restoring shouldn't be that bad at a glance. Yeah, I don't know what the best way to do this is. Because we also need to pass it liveness info probably if we want to be like efficient about it, unless we want to just literally save and restore every register at each call. Let's go Fortnite Gamer. I haven't seen you in a second. Hopefully you've been doing alright. Yeah, there's lots of chaos here, because cogen is hard. Cogen is really freaking hard. Let's go there. Can I just like default a lot of these? What happens if I default them? Or I guess... Well, I don't know. We'll deal with that in the refactor. So this is called generate. What are we calling this? Calling convent, or I guess generate, or I guess like generate call preamble and postamble. What's the combined term for preamble and postamble? Paratext. Okay. Wrapper? I don't like this. I really don't like it. Okay, we're not gonna ask ChatGPT for semantic help anymore. High-tile modding is harder when every update breaks something? Yeah, I mean, it's like, it's a young game, right? So, I imagine it's not really stable. Why are you using GPT? Because I am not creative, so I'm going to outsource my creativity to something else uncreative. Generate call, I guess like call pre-post amble visitor. I don't know. We'll do that. Is codex? Nah. I probably should just like stick things in Claude, but I don't know. Whatever. I don't know. What do we even call this? Calling convention? I guess. Or I guess we don't even need a visitor for this. We can just use dynamic cast now that I think about it. If this is a singular thing we're checking for. So I think dynamic cast is actually pretty justifiable here. And then we can do fast dynamic cast in the future. So for auto instruction or I in instructions. Yeah, so we need to throw all of this into here. Yeah, so then false. And then the rest of this is fine. We can just like clean this up. So we want dynamic cast. Yeah, so we want that star. Did I include a header? Yeah, whoops. Yeah, so we need that, and then we give it I get. Yeah, and we can just skip otherwise. So then here has call equals true. So we definitely need that regardless. Then now this is the rest of the slush. That's not a header comment here. This is save slash or I guess manage or preserve callie save registers. Preserve caller saved registers around calls. And I guess and here maybe. What else do we put here? And manage function params args, I guess. You can do that. Yeah, we can write it like that, I guess. What happens if I join that and then format? Okay, well that does exactly the same thing. I guess that's wonderful. Okay. Yeah, this entire function just needs a lot of helpers, unfortunately, but that's kind of just life. Or it's just going to be like a lot of comments because I don't want to separate these out into helpers. Yeah, so let's, how much space do we need? Or how did we loop through two things at once again? We did this in liveness. Yeah, so we want like this as well. And then we want index plus plus at the end. I guess we want this. we could put those at the top as well. That actually seems a little bit cleaner. Yeah, so we should iterate that every time anyways. Yeah, okay. So then here we want to allocate space. This is kind of confusing because what even is live, at least? Let's print out liveness around a call somewhere. So let's go to the driver, or actually, where do we want to do this? Probably in regelloc? Yeah, let's print liveness. What does this take? A function as well. Okay. Yeah, I want to set up a fuzzer eventually. I think it would do my code a lot of good. Because I'm kind of just assuming well-formed programs for the most part, but I think we get problems when we get malformed programs that parse correctly. Okay, so let's run. Let's do call chain. That might be interesting. Okay, so we have a call here. So everything in kill? Actually, what's... Yeah, that's very confusing. I guess maybe we should run it separately, actually. Let's actually just not print it here. Maybe we just print it up here. Let's do that, I guess. Okay. Oh wait, this is O0. There we go. Much more usable. Yeah, okay. So we have all this slush, we have call. So I guess we can kind of figure out what's alive at this point. I don't know, it's kind of awkward here. Because like we kind of have a bunch of dead registers. Maybe I should use the full registers in liveness. That might save a lot of headache in other parts of the program. I don't know. Yeah, this is very awkward. I guess passes mem to reg. What does this code look like? Why is it quitting here? Why is it only reading one function? Oh, we're returning continue. Whoops. Okay, well that actually changes a lot, huh? Let's do that. There we go. Much better. Yeah, I guess this doesn't really help me a lot, actually. Maybe we give it... Let's give it, like, params. This one might be more interesting. Yeah, okay. So we do like this, which is rough. Yeah, okay. I don't really know what to do with this. I guess we could just look at in. You could look at everything at in, and then like, if it's, oh man, this really sucks. Okay, well, I need to use the bathroom real quick, so I'll be right back. Yeah, don't burn down the house while I'm away, you know the usual. And we're back. Okay. Yeah, so I was looking at this. I think, of course, naturally, as everyone does in the bathroom, they come up with their best thoughts. And I was thinking about this, and I think we should change the way we read through kill here. What's good, blueberries? Skittles. Name. Hopefully your classes are doing well. I am in cogen hell per usual. I think I do need to change liveness here though. Yeah, gen should be all the registers used, which is correct, but I think kill should be RAX specifically. Just finished my first OOP project. Ooh, fun stuff. What's good, moderator Vlad? How to use tmux in Windows and what is this terminal? Yeah, I guess I could go with this a little bit. So like the big thing that like makes Windows remotely workable is WSL. So WSL. So World Surf League. Yeah, it's this. So Windows subsystem for Linux. It's basically like a Linux VM sort of, but like with better Windows integration. There's like some like quirks here and there, but for the most part, it has been pretty smooth sailing. I think like if you have a very niche use case, you will probably not enjoy it. But if you're just like writing like C++ code, or just want like a dev environment for like Linux utils, I think WSL will generally do the trick very well. So that's how I have tmux in here. And then the terminal I use is westterm. So yeah, I quite like westterm because it's Lua configurable. Generally it's just like very well configurable. It's written in Rust, which everyone likes, and it's just pretty performant. I believe when I was like first reading into WSL, I was told that westterm has like pretty good integration, so that's why I ended up picking westterm. But I don't think the terminal really matters that much. Like I used the standard like Windows terminal for a while at least. But yeah, I think WSL is probably just like the big thing that you're looking for. The big thing is in my WSL root, because this is like, yeah, so this is like a separate, I guess it's not like the same file system. So there's like, to get to Windows, you have to go through like mount C Windows, and then like you can go from there. So what I have in my root, I also have, I have this like Windows alias, which makes working with Windows files in here a little bit less awful. But yeah, that's kind of like the short version. Hopefully that is of some assistance to you. Okay, so we need to change call. We need to change liveness for call. Also git status, git add -p. So we don't stage that. We don't stage that yet. We stage that. Yeah, we can just commit it, right? Okay, nice. What else do we need to do? I guess we could... Yeah, I guess we should probably change liveness real quick. Yeah, this is so much nicer to maintain than I was expecting. Yeah, let me know if you have any other questions. That's good, Lynn. Good to see you. Thinking of getting reacquainted with Zig. Ooh. Yeah, I've never worked with Zig, but it seems like it would be a lot of fun. So I think that might be valuable as well. Okay, so we need to change kill. Because our current kill assumes like saving registers. Or I guess assumes that like the registers have already been saved. So we need to change that at least. Where is call? Here it is. Yeah, so this is in fact not correct. Caller saved registers are not included, as that's handled implicitly saved through calling convention later. Okay. Okay, so this is the only place that like we do mess with that. So reg is a register num. So we want to instead, we want to add register num. We probably want just rex, I think. Yeah, we'll just do that for now. I should also probably flatten in here as well. Let's see. Let's regenerate regression tests. Oh god, I forgot we vomit out all output. Let's actually look at some of this real quick since we're here. Hopefully not all of it has been zapped away. I guess we just have to rerun this. What control stack and heap memory? Is it the operating system or compiler? It depends on what level of the software you're looking at. So like at a literal like code running level, the OS manages like actually, how do I even explain it? I guess both. I guess both manage stack, or both control stack and heap memory. So the compiler does control like stack memory insofar as like if you look at the code that I'm generating here, or attempting to generate, where's the good example here? Maybe params? Okay, well, it's not shown here because this has optimizations, but if you're like, actually, let's turn off mem2reg and then rerun it, and that should work for what I want. Yeah, so like here at the top we do like, we like subtract 16 from the stack pointer, at the bottom we re-add that back. That's like controlling stack memory in a sense. I guess kind of in a very literal sense actually. In terms of like heap, that is like operating system managed completely. But yeah, this is kind of like, at like the compiler level, we control like stack memory insofar as like we mess with the stack change. At the OS level, both are managed insofar as like the OS allocates, or I guess the OS hands out however many pages the program needs, both for the stack and both for the heap. So like, whenever you start up a program, the OS is like, okay, this is a program, let's give it like X bytes of stack memory, X bytes of heap memory. And that is like, that's at the OS level, at least. Not sure if that answered your question, but that's kind of like the fast explanation. .NET dev, but I moved to Pop! OS to try it. That makes sense, yeah. I think if Windows, like, if you have a strong reason to like not use Linux, or specifically a strong reason to use Windows, I think that's fair enough, honestly. If you're using like NeoVim, I think you could probably install it through like Chocolatey, or like whichever of the big Windows like package managers exist. I know that exists. I think I actually have it, but I don't want to open up PowerShell right now. So yeah, it is something you can do. And then like Westterm is just great regardless. I think you should use Westterm. If things were always breaking, we wouldn't have modern ghosty. That's so real, yeah. I don't know. Everything being unstable, I think just generally encourages a lot of change in positive ways in the coding space. Or at least at like the systems level. I think maybe at the web dev level, there's a lot more just papering over things, but what do I know? Yeah, okay. So then, okay, so at this call, oh, this does gen everything here, and then it kills Rx, which makes sense. Yeah, this looks about as expected, I think. It doesn't look like any of these are live at a later point, so I think this is fair enough. Yeah, so everything, we could look through the inset at least. Yeah, we could look through in for everything that's live at this point. Live before this point. And then, oh, and then we could look at out for what we restore. Oh my god, wait, we're cooking. We're actually cooking. We're cooking with gas right now. Okay, let's make sure that this returns. Okay, so these are all just the 64-bit registers. So that will work well. Man, I should just update liveness. I'll do that after this. That will be the detour for today. Okay. So yeah, let's loop through all the registers. So I guess so we want gen I, and then, or we want in at I. So we want like, we can stop printing liveness as well. This should be ref. Yeah, so we can do that. Yeah, so in and out actually lets us just be more efficient with which registers we restore. So in lets us like, or save and restore. So in lets us save only the registers that like we care about a value in. And then out lets us, I guess, restore registers that we... Actually, wait, do we only care about out actually? Or no, we should definitely save in, actually, yeah. We definitely need to save in, I think. Or that would be safe to do, at least. In the event that, like, we have parameters and stuff. Realistically, we could probably just save only everything in, like, out. But just to avoid complications with, like, parameter order, I think we should save in as well. Yeah, so we can do that. And out is also by ref here. It's in at I index. Then we have out I equals out at I index. Oh, broke the semicolon. I have a MIPS program due tonight. That's rough. Yeah, good luck on that. I'm sure you'll be fine, but good luck in case you need it. Aye. Okay, there we go. So we can format it like that. Okay, so we can do this. So we have the in and the out. So then, or we could actually just like, we can do that instead actually. So we can loop through this. So reg is a register num, I believe. Oh, we should get caller saved registers as well. Right? Do we have that? I feel like we saved that somewhere. We have callee saved, and then we need caller saved as well. This is a set, so we could actually loop through it the other way, actually. Now that I think about it. Yeah, I like this. So we want caller save registers here. So if in I contains reg, and then what's encapsulated in caller save registers again? Rx is in here, so we need to ignore that. Oh wait, this is a literal register? Oh. This is reg. In I is unordered set. Oh, we need to get the actual register. God damn it. Okay, this is fine. So reg, or I guess like reg putter, or we can make this like reg num. We can just do a skip here. Yeah, we'll just skip like that. Yeah, okay. Do I need this? I don't think I need that. We'll find out the hard way if we need that. A lot more homework this semester, even though my classes are even more exam based. I see. Yeah, I think this semester is also presumably longer, right? Just because it's like, or actually, I don't know how your school system works. I guess you started late, so maybe not, but yeah. I mean, I guess that's kind of just how class selection goes. Okay, we can get rid of this. Yeah, I don't know, like, course selection at my school is kind of just like Shark Week, so it's kind of just doomed. Yeah, so we want to skip like that. If out I contains reg, then we want to do something else as well. Oh, wait. This is out. Somehow I'm not familiar with MIPS. But yeah, generally, oh, I see, yeah, it's the, I say. But yeah, an immediate is generally used as, it's generally used to refer to, what the hell? Oh, I see, that's what's going on here. Generally an immediate is referred, an immediate generally refers to just like a numeric value, or I guess like a hard-coded value as opposed to a variable. Or I guess a hard-coded number, I guess byte value, bit value, distinct from like a register, distinct from an address. Had immense luck with my reg? Damn. Yeah, here it's like the first 2 years you get kind of just screwed by reg, and then like the third year you kind of have some fun. Right now I have like master's reg, so it's kind of been fun for me at least. Okay, we actually need the iterator actually, I think. Yeah, so let's so we want instructions, begin. Yeah, so we can iterate through it like this. Oh, this is not ref. So this is so awful. So we need to do that. C++ is so funny as a typeling. Yeah, it's just so much auto. But I think that's kind of how a lot of languages have evolved, actually. Yeah, hopefully your coursework is going alright, Aiden. I mean, you have like a brief reprieve from PL, right? So yeah, the whole existence of auto is really funny if you just look at the evolution of programming languages. So like, let's go to paint.net. So like, there's always just been a little bit of a divide between like typed and untyped languages. So like, we started with like typed because, well, hardware, and like encodings and stuff. So that's kind of inevitable. And then like we eventually end up with like untyped somehow. And then like this was nice because then like it's more convenient to work with. But then like eventually like somewhere around like the 2000s, we all realized that like maybe we should like, all the untyped people were like, maybe having some types would be useful. And then like the typed people were like, types, we agree types are useful. So they didn't actually like care about untyped at that point. So then like, this is where like gradual typing or like, I forgot what it was called. It was like replacement typing or something like that. It was like, gradual typing is like the modern name for this, at least. There's definitely like other names. forgot what it was called, but this is where like gradual typing came from. The idea is like, if you're going from an untyped language to a typed language, or generally like you probably have like a big pile of untyped code, and you want to like take this and you want to turn it into typed code somehow. So the idea is like, we want a type system that is like interoperable between the two, and then it just turns into the typed language just by like adding types. So the term for this is like gradual typing. Or not, I think it's not gradual. I think it was like, there was a different term. I can't think of it. Let me check the slides for one of my classes real quick. I should not, this is like one of the things I actually should not leak. But there was a very, very specific name for this. This is very important to me. I need to get this correct. Let's look here. It was in this slide deck. Okay, GitHub, sure. Migratory typing, that's what it was called. So we have like this whole idea of like having a type system that like, that I guess supports both typed and untyped, while generally trying to encourage use of the type variant is like called migratory typing. And like, I think the name kind of makes sense because, well, the whole point is that we want to like migrate our code from untyped to typed. And then like this name didn't stick, which is why I had to look it up. And then like the name that chose to stick for some reason is gradual typing, which refers to a different thing. But this is like what TypeScript uses. So yeah, that's like the whole big like untyped to type movement. And then nowadays we see like, it turns out that types are really annoying to type sometimes. If you look at like something as basic as just like an iterator in C++, but also just like monads, for instance. Like monads in like a functional language or like a functional style of programming. So now like there's also this like, there's this whole trend of like typing going the other way as well with like auto and like type inference. So yeah, that's all just like a big like PL/PAL. The bottom line is like, it's really funny that we're going in this direction as well, and I'm all for it. Is assembly untyped? It's typed insofar as like you have sizes, but like everything is just like bytes at the end of the day. So it's like sort of typed, but like not in a convenient way that we care about, I guess. Okay, so we need to, let's like actually continue this stuff real quick. Yeah, so the first thing we need to worry about is saving caller saved registers. I guess we're working in to out, right? So, or out to in, I guess. So we want to like save all of these first. Yeah, this is very annoying. This is super annoying. Yeah, okay. Let's loop through this first. I guess we just need to track which ones we want to save first, and then we can generate the instructions for it later. But out we can definitely generate first, I think. Or wait, no, we have to, sorry. We have to deallocate space first. So we want to generate this deallocate and this allocate first, because we're just like inserting around this call iterator. And then we want to generate like saving and restoring registers, and then we want to figure out param registers in that order. So this creates a bit of a mess. So we want to make like a save buffer and a restore buffer, I think. And we want the registers, I believe. So I guess let's make a vector of LR register star save and then restore. I think we can just do that. Nice. So then here we can actually just clean this up a little bit. So you want to save that or push back, I guess. So then here we want to save to restore. Yeah, we can do that. Let me just move my mic so I'm not bonking it all the time. Okay, so we have all of that. So that gives us the number of color saved registers we want to save, or at least at the start. Yeah, so we can do that. Let's actually from in. Yeah, there we go. So we can do that. So now we need to allocate space. I guess this is stack space, and then we will have something for save, restore registers. Yeah, and then last we want to worry about store params. Yeah, we're just gonna be like really greedy with this. So let's make stack space, or we already have stack bytes somewhere, right? Total stack bytes. Let's rename this function stack bytes, just to be more verbose with it, or more clear with this. We can make this call stack bytes. Did we specify the type for this? No, it's just auto. Or I guess unit 60. Yeah, we'll auto it until it becomes a problem. So we want. Let's make something really unreadable. So we want color save registers, param 7+, and 16-byte padding. So we start with the number of color save registers. It's 670. That would be funny. Let's do this until someone yells at me for it. I feel like I end up typing that a lot by accident, but anyways. So we want to start with in or save size times 8, I think. 8? 8. And then alright, let's do some heinous stuff as well here. Do we count here? Let's do. So we have the function, right? We have f. Yes, we have f. Get num params. If this is greater than 6, then wait, we have num params somewhere, right? Right? Surely we have num params. Oh, guess we don't. Okay. Okay, sure. Let's do that. So if it's greater than 6, then num params minus 6, else 0. Let's do 8 times save size, and then we can. I guess these also need to be 8 as well, so. Oh boy. Yeah, so we can just do this ugly thing. Okay, let's put the times 8 at the end. And then we need to pad this as well. Maybe I should just make a pad helper. Pad to 16. Yeah, let's do pad to 16. Actually, wait. I guess we don't even need the second check then, to be honest, right? Because if it is aligned with 16, adding 15... Yeah, because then adding 15 wouldn't overflow it. Yeah, let's do it that way. Oh, wait, we could be very heinous with this, actually. Wait. Wait, this is a terrible idea. Let's do it. Let's make this even less readable. So let's wrap that. That's not what I wanted. Let's go with that. Oh god. Okay, wait, this might be too much for me even. I'm so happy I made this. I'm so happy. What happens if I auto this? What type is this? UN6014. Nice. Okay. I'm very happy about this. This formatting also makes this just incredibly unreadable. So maybe we don't do this. Yeah, I value readability a little bit more. So let's yoink that. Let's make that. Aye. I need a semicolon. There we go. What am I doing? Okay, well, I mean, that works. So we have the number of bytes there, and then we pad it. So we can work on that, and then we need to generate the alloc and dealloc. Yeah, we can just copy this, actually. Or we actually just need to copy all of this. Actually, can we do something interesting here? Maybe we can make a lambda to simplify, or deduplicate. What is reg? Oh. Yeah, okay. Let's make a lambda. Might that be less readable? That might be less readable. Let's make a helper function then instead. So we want void insert, I guess like alloc and I guess like manage stat or create. Oh, but then I need to... Okay, no, I just realized. Then we have to pass in the thing, and I don't want to pass in the thing. I don't want to pass in the iterator. That seems like annoying. So I'm not gonna do that, actually. We're just gonna copy paste. Maybe I could use a macro, but whatever. I think it would be more miserable if I were to change that up. So let's work off of this. So we can get that. And then instead of instructions, we have to do... Where was the thing that we did this before? I think it was here, right? Was it coloring? Oh, no, it was spilling. It was spilling. That's where we did it before. Yeah, so we did like this thing. Yeah, okay. So then we just want to yoink this. Instead of iter, we want iter. And then this should be allocate. So this is the load, so this goes before. And then we need to do some more heinous stuff here. And then instead of store, deallocate. Yippee, okay. I think this looks about right. So this makes the bytes, this gets the right number, this makes the sub, this makes the add. Yeah, we'll just, so this is cleaned up. This is cleaned up. All right, yeah, this looks correct. Let's see where the tests fail. Oh, what the hell? That's not supposed to do that. Oh, I used 3 and 4. That's why it failed. Whoops. Okay, I think there is permission to execute me as a C++ programmer that indexed by 1 by accident. So yeah, it's over for me. Okay, let's rerun that. Okay, that fails some tests, which makes sense. Yeah. I guess we should just skip if it's 0. So if it's not 0, then we want to do all of this stuff. And that's like one more layer of nesting, but whatever. Yeah, this is a chunker. Wait, what? Oh, it's all zeros? Wait, what? I mean, fair enough, I guess, but yeah, okay. Well, that makes it hard to test this, huh? I guess if it was 0 before, then surely this is correct at least. So what did we change? So add liveness. Move, what's it called? Remove caller saved registers from call gen or kill. Yeah, we're assuming that these are handled correctly at least. Okay. Let's diff this real quick. Yeah, so we have in and out. Yeah, so we just extended all this out. legal, we'll just do that. Typo. So we can, we say we scaffold call caller commit convention implement space allocation. Let's update the test again, actually, because I think we have a way to make it preserve a register now, or at least I can think of a way. So we have what's it? Params? Yeah. Call many, I guess we'll just make this. So we can do like what? Fun one with like 5 or something. And then we have, or we could make this like main even. So then int j equals call super fun. Let's give it like second and then I maybe? I. Int k equals like, let's just wrap call to again. Let's give it first and then j, and I actually. I plus j plus k. We'll just make a mess out of this. Oh wait, duh, this doesn't work. Call many. Let's make build real quick. Let's generate regression tests. Update regression tests nondescriptly. Yeah, let's look at the params output now after rerunning all of that. So if we look at the assembly, do we have a sub? Not where we care about. Let's look at O0. Huh. Huh, okay. I guess we're just not generating it yet for some reason. I guess maybe we need like more values to work with here. This is O0, so... Dear lord, this is ugly. Let's do this with mem2reg, actually. Let's add a mem2reg for this. And then this passes is pretty boring. There we go. So now we can look at some more interesting stuff here. Okay, well, we might need to be even more aggressive with the test case then. I'm trying to get it to a point where I actually have to save something, but well, obviously I'm struggling a lot with that. I'm not sure why. I'm not sure why I'm struggling with that, but here we are. Params. We might just need to like call more things. Or we want like super fun here actually. Let's just make a mess here. Okay, yeah, that's the correct number. And then we want to do something here as well. Let's give it like this is so stupid. Let's go J here. Let's go to Adam. Yeah, we'll do that. Let's regenerate the tests. We will do heinous things here. And it's not making space. Why is it not making space? Yeah, this is annoying. This is very annoying. Are we cooking today? We are not, unfortunately. Let's make J here. Do you dye your hair again? It looks quite blue. It was like last weekend, I think. It just shows up as really blue on stream for some reason. So I guess that's kind of life. Evidently, I'm very hungry, so I might have to cook eventually, which is bad news. Anything new here? No. That's annoying. How much you spend on hair dye? Too much. It's it's kind of scary actually. I really should try to be more frugal with it, but also like I don't know. I will make enough money to sustain my lifestyle. Hopefully. Okay, we might need to like do more slush here. Binding vow, yeah, that might be it. Compiler. Okay, so we just added an addition here. That did not help me. What can we do that where we need to like preserve a value somewhere? Yeah, this is rough. I guess we need a bunch of function calls. So let's do like J, K, L, M. Let's do like I, J, or we could do like super fun again. I don't know, this is a hard test to write, I think. My mom lives in England and you have to pay for water bills. Yeah, in the US there's a lot of like utilities that just need to be paid, for better or for worse. Could you do Fibonacci? That could be good, yeah. Actually, yeah, I might have to write that test. There's no way someone in the stream had the username Fortnite Gamer. Yeah, Fortnite Gamer's a regular. They're pretty chill. I'm quite happy that they show up frequently. Let's do that. Let's do L here. And then let's reuse I at the bottom here, maybe. We'll do that. Oh, wait, we could do this easier, actually. It just occurred to me. I guess like pressure. Let's just throw more of these in here. So we should just do like 12 of these. As an example here. That might be useful. Why am I typing this by hand? Okay, let's yank this. Let's paste it down here. Y'all are about to see a fire macro. So we're gonna start macro 0. Let's get rid of that. Let's clear the rest of this. Let's replace this with a plus. Next line. So now we select these norm. We run the macro on all of it. Let's get rid of that last thing. And then here we can do 12 and then J. Or wait, we might just have to spam J like that. And then we have to format it so I don't go insane, but yippee. Actually, what does that look like? Actually, yeah, let's just format everything. Fuck it. Yeah, so now we get to call super fun on all this. Like, let's do pressure 1, first, second, first, second, first, second, first. Something like that. Plus J. I guess super fun. Like that. There we go. So hopefully this makes a mess. Do you play blackjack? I've played it before. I don't really get an opportunity to very frequently, so yeah. Where's the call? Where'd it go? It's at the top? Seriously? Okay. That's irritating. I guess that makes sense. Let's make a macro here. There we go. Let's run that again. Or wait, 8 at 1. There we go. Yeah, okay. That's nice. We're just going insane with this test here. Did we do it? I don't think we did it. Yeah, we're not saving anything here. That's kind of annoying. I guess we probably need all of these then. So we should probably... This is so stupid. What am I doing? Let's rename this. Let's just give it like first here at the end, just to troll. Let's just rerun. And we still don't save anything. Are you serious? Wait, what? Oh, no, we need num params of the function being called. That doesn't help me though. Fuck. Okay. Oh, wait, no. We can do... What was it called? It's call get args size. There we go. That should be correct then. That's why I wasn't saving anything. Although, I guess we were checking for it saving something in a different place anyway. Anyway, we need to regenerate tests. Okay, it's just params which changed, which, fair enough. There it is! There's the save. Okay. That does exactly what we wanted it to. And then this should also appear as well, right? Yeah. So we also just need to like move the parameters into the right place now, which we're getting there. We're definitely getting there. Oh boy. Okay, this is just a slush function. What is happening down here? What the hell? Oh, we spilled some stuff. I see. Did we spill stuff? What is... Oh, wait, no, this is saving registers. I see. Yeah, wait, this is saving the collie saved. Okay, cool. That's really cool. I just tried to use Vim to edit this. Can I just do this? Yeah, this is way nicer. What do? We save or count args of called function or callee, not caller. Date param plus test plus generate. Ay. Okay, cool. Alright, so that's this slush pile done. So now we need to save and restore registers. This is a mess. I don't think we have a great way of testing that, at least. We probably want to make more registers then, right? I guess what is even happening there? We're looking for params s. Think learning any more than 4 languages is too much? Yeah, I don't think you need more. At least at once. You can like kind of pick up bits and pieces of multiple languages at once though. Yeah, that could be something to think about. Maybe that will make things easier. Let's see. What are we missing here? Do we need more registers? Oh wait, these all need to be used later. I think that's what this test is missing. Wait, the gears are finally clicking. Oh wait, no, we do use them later. What? Wait. So what is... let's look here again. Oh, do we spill all of these? Is that what happens? Let's go Jatsu. Would you say this kind of project is easier with C++, or does it make it more cumbersome? I think maintenance-wise, C++ makes it easier, at least in the middle end. But I think in the front end, like, I would prefer a functional language, to be honest. I think like, if you've seen like all the visitor patterns I've had to write, I think that is the big thing that I wish I didn't have to do. I think a functional language would help a lot more with that, just because like, there's more powerful like pattern matching that I think would help. Like OCaml would probably be helpful in some instances, for instance. C++ your best language? Not really. I don't think so. I don't really know what my best language is though. Actually, let's go up here. C++ is faster than Rust now? My research work leaves that inconclusive. I don't think it's very easy to make blanket statements like that. Let's at W. We're just making such a mess here. Holy hell. Alright, I don't need to make build. Oh, is this not valid? Oh, I don't have postfix yet. Whoops. Yeah, okay. There we go. This is some insane stuff happening. And it still doesn't do what we want it to. Okay, you know what? It's fine. We're just doing some slop. Maybe we need more registers here then. I don't know. We're running out of registers that we can use. This is just like the triangle again. This is kind of what we've done. So I think this means there's something wrong with my code somewhere, but it's like whatever. Looked up the charts. I don't think the charts are very representative, at least. It's hard to like really determine like what fast is because there's like so many different use cases for every language. So I think it's very easy to get caught up on numbers, but yeah, there's a lot more than just like fast in a vacuum, at least. And we still don't do what I want it to. Okay, that's fine. That's fine. That's perfectly fine. Yeah, I don't know. I'm not understanding what's happening here very well. I guess we're like spilling something. I don't know what we're doing with that, but something is going wrong. Is 16 the right number? That's 2 stack variables. So that's just the 2 extra params. So maybe we're maybe we're not doing get args correctly. Is there a size thing happening here that is going wrong? Let's do 2 size. Then we do quad word. I guess. Let's do that. Let's do that. There we go. All the best, bro. Thank you. Alright, let's see if this makes changes. Well, we just made things bigger. I don't think that... What else did it change? I'll be back. Sounds good. Thanks for stopping by if you don't end up coming back. Dear Lord, this is a mess. Yeah, it's all params. Okay. I've been fighting with this test for so long. I don't know why this is like as difficult as it is. I feel like it shouldn't be this difficult. I'm not understanding why this is giving me so much trouble, at least. I feel like we should be saving more than this. Or I guess these are dead after, so we probably need to... I guess we could get rid of this at least. We'll try that. I wanted to save more than 16 bytes, if at all possible. Unfortunately, it does not appear to be doing that. Color saved. Okay, so this is the right one. We're saving all of these correctly. And then we pop them correctly at the end, I think, right? Yeah, we do. This is very irritating. Let's just like clean this up like this. We'll just do that for the macro. And then we can do that. Okay. This is like very odd. What is happening here? Why are we adding... What is happening here? I don't know anymore. This doesn't make any sense. Where did the call go? Okay, it's here still. I'm like really struggling to do this. Let's just get ChatGPT to update this. I'm getting quite tired of this. Let's go daily up. Volatile. Okay, that doesn't help me. This is not helping me. Oh god, wait. Yeah, okay, that makes sense. You know what, we're just gonna copy this, and it's also smaller, so Or it looks smaller. Anyways, we're just gonna blow it up immediately. And, okay, well, it still doesn't work. Okay. You know what? That's fine. This is fine. This is fine. I'm just... PMO. Okay, we're just gonna... I feel like this should work. Let's just give it this code, see what happens. Oh, I guess that makes sense. This doesn't make... Wait, what? Wait, what? This should be working. No, this is not what I'm. No, okay. This is PMO right now. Am I getting like bunked over the head by ternary operator right now? What the fuck is happening? Oh, I see what you're doing. Yeah, okay. If you say, yeah, sure. Yeah, but whatever you. Is this a parsing order thing? Wait, this might be a parsing order thing. Surely not. Surely it's not that. Why is this taking really long? That didn't work. Why didn't that work? Okay, we're just gonna... We want this. What the fuck? Okay, you know what? We're gonna debug this by hand now. At this point, this is not helping me whatsoever. Let's see out. Save size. Yeah, we're just gonna do this. I'm like going nuts over this. This should be working. Let's run. Wait, what? Wait. What? Did I build? I didn't build. Okay, that makes sense. Okay, so it's just 0. That's odd. Let's just print reg. Or let's... give it sized. Badge num. I'm not good at this. I'm not good at this yet. Oh, I forgot to new line. Keep up, man. You've inspired me to finish crafting interpreters. Ooh, that's good to hear. Thank you. Need some rebuild. So what is the in and out for this? Wait, what? Why don't you use Linux? Because Valorant. I don't want to dual boot, and WSL does what I need it to, so I've decided against it, at least for the time being. Rebuild. Okay, let's look for the call. Can we like... There we go. Wait. Here we go. Wait, what? Why is this not... Wait. Wait, what? What? Huh? The Haley? This does not bring me joy. I'm not really sure what's going wrong here. Ay. How has this gone so poorly so quickly? This was supposed to be like a half-hour stream. Okay, so we just don't find Foo, I guess. Oh, wait, the in uses the 32-bit. Oh. Okay. Let's just do... This is so stupid. This is actually so stupid. So this should fix it then, surely. I'm actually like going insane looking at this. This does not make sense. Ah, here we go. We have Foo now. Yippee, wait. Oh, we're printing at a different point. Okay, let's get rid of this print output now, because I think this is correct now. Clean up, clean up. I think this ternary operator has precedence, so this shouldn't matter. Oh yeah, some of the params tests are giant because I made a mess here. Okay, let's look at this again. Dear Lord. Okay, so maybe this precedence thing did matter. It's gonna take a second, huh? Something tells me this many registers was a mistake. But I mean, it should work. Yippee! Okay, we have a big number now. Let's see if we can make this less awful now. Compilator time, yep. As always. Delete 6-word. Yeah, there we go. So then this should also just be less slow as well. This should still have a big number. Wait, that was an even larger number than I remembered, I swear. I'm not sure why, that's odd. Yeah, this is a larger number. Why is it 80 now? Interesting. What happens if we get rid of this? Wait. Oh, I think we spilled something, which is why this was making a mess. Okay, well, that's cool, I guess. We can do that. I guess space generation, maybe? Heinous param stuff. Okay. I think that's probably a reasonable place to call today. Next time we can figure out actually saving and restoring registers and then figure out how to handle params. And then I think we're pretty much done with this. Then we just need to generate a little bit of like global entry point stuff. But yeah, we're quite close to generating code, or generating executable code. But yeah, I'm gonna call the stream here. Thank you all so much for showing up today. If you haven't already, make sure you like the stream and sub to the channel. While you're down there, check out the description. My Discord is there. So is my LinkedIn, my GitHub, and my GitHub sponsors. Feel free to add me on those or support me financially if you wish to do so. Yeah, I'm gonna go eat now because I haven't eaten today. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.